Do you guys want to start with some questions here? AJ.
So can you do in the notes now for this example for the worksheet, this example of one from the sixth?
From the 6th? One of these?
Yeah.
Actually, let me just grab that. Okay. So let's say, what do you want to do? Just the first one? So first thing I want to do is to rewrite this in kind of my standard transformation form so I can pick out the values for A, C, H, and K. So right away I can see that A is -4 and K is 1, right? So let's figure out the C and H piece. So what I'm going to do first is I can see that the coefficient on my X is going to be the 1 over C. So if 1 over C is 2, what is just C? 1/2 is correct. And then is there anything being added or subtracted from the 2x? No. So what does the H have to be? 0. Oops. Write an X there. Cool.
How is 2?
So if I do 1 over 1/2, that's the reciprocal of 1/2, right? And that's just 2 again. So all I've done is I've rewritten 2 as 1 over 1/2. It's still the same number. It just, I need it to fit so it looks like that. Alternatively, you could think about it as like 1 over C equals 2 and solve for C, where you'd like, you cross multiply and then divide by 2. And you do it, think about it that way if you prefer. That's fine also. So we've done that, right? So if I want to describe the transformation, we do, C goes first, right? Yeah. So since C is positive, there's no reflection. Since the absolute value of C is less than 1, we have a horizontal shrink by a factor of 1/2. Since A is negative, we have a reflection across the x-axis. Since the absolute value of A is greater than 1, we have a vertical stretch by a factor of 4. Since H equals 0, there's no shift left or right. But since K is greater than 0, we are going to shift up 1 unit. And then I think it asked for, what else did it ask for? Domain, okay? So the domain is always going to be all real numbers for any sine function, regardless of how we've transformed it. The range is always going to be absolute value of A. Hold on a second. K minus the absolute value of A, comma, K plus the absolute value of A. So that's going to be -3, 5. Then we ask for the amplitude. That's always the absolute value of A, so that's just 4. The center line or midline, that's always y equals k. So in this case, y equals 1. Period, which is always 2 pi absolute value c. So in this case, our c is 1/2. So I just end up with pi for the period. And the frequency is always 1 over pi. Or I'm sorry, 1 over the period. So in this case, 1 over pi.
Do we need to like remember this stuff for today?
The amount of memorization should be minimal to do the problems if you've practiced the problems. The actual, in practice, aside from doing one like this where like I literally just used every formula that we had, there's not that, it should not be so memorization heavy, although there are certainly things that you probably need to remember. But there are things that we've used in like every problem we've done for the last week, which I think are probably doable. Like you probably need to remember this form so you can pick out the A, C, H, and K, but we've been doing that forever, right? Like you should know that form by now because every single problem we've done in this chapter, you've used that, right?
A sine 1 over C X minus H plus K.
Good job.
It's right there.
Like
I wasn't looking at
should you know the amplitude is the absolute value of A? Yeah. Do you remember that? Do you know the midline is y equals k? Do you know the period is 2 pi absolute value c? We've used that to do every problem that we've done in the last like 2 weeks, right? Like that's the kind of stuff. Like, should you remember those ones? Sure. Do you need to remember the transformation stuff? Not right now.
That's more of what I was.
Okay.
Yeah, I was.
In the graph to equations, this is the amplitude. This is like plus or minus. So
Yeah, because if I know the amplitude is 4,
yeah,
that would tell me A is equal, or absolute value of A is equal to 4. So A could be positive or negative 4, right? We don't know if we're going from graph to equation until we've picked the point that we're going to, think of as our transformation point. AJ.
Do number 7
On worksheet, which one?
worksheet 2.
1 over C
Sure.
minus H plus K.
You said 7.
Yeah.
Okay. So minimum at 3.0, maximum at 23.20. So like our graph kind of looks like that then, right? Good with that? So far, so good? So first thing that I'm going to do is I'm going to pick whether I want to write a sine or a cosine function because the problem doesn't tell me which one to do. So I have the freedom to choose which one I want to do. Now you can make your life easier or hard by choosing here either smartly or carelessly. If you're given mins and maxes in the problem, we should choose to use a cosine because the parent function point that we use when we write a cosine function is a maximum. Okay? If we're given midline point, I would use sine. If you're not specified the type of point it is, I would use sine and make it a midline point. Okay, but that's the first order of business, so we're going to use a cosine. So let's say we want to find the midline, right? Which should be halfway in between the max and the min, right? So we're looking, what's halfway between 0 and 10? 5. That's the midline. Y equals 5. What's that also tell us? K is 5. If you like a formula, you can write it that way.
Wait, is it 23 plus 20 or 20?
Oh, should be 20, I guess. I just misread. Thanks. That was my own fault for writing that 20 so poorly.
So K is 10.
Yeah, so K should be 10. My apologies. Everybody's okay with that? So this would be my amplitude, right? That's half the distance between the max and the min. Or you could think about it as just, you know, going from not half of K, but the distance from K to the maximum, which we can see is 10 here, right?
Oh, that's why.
It's not necessarily half, it's the distance. Or if you like formulas, it's y max minus y min divided by 2. So it should be 10 still. But that's actually the amplitude. So what that tells me is that A should be plus or minus 10, right? And again, you can do this with formulas, or you can just kind of look at the picture and like do some counting, right? Because all we're doing is like counting up and down. It's not super difficult that you need to use a formula, but the formula is a convenient thing for me to write down. But like you could count it if you understand like amplitude and midline, what they mean geometrically. You can just look at the picture and count, right? If you get stuck, just count. It's okay. It's the same thing we did when we were given the graph, right? We just counted. Like we looked at where it was at and just counted up and down and stuff. Same idea here. Next thing we're going to do is figure out the period. So this is one period, right? But we don't know what this point is. But we do know where that is. How much of a period is that? Looks like half to me also, right? So that's just going to be the distance from x to x. How far is it from 3 to 23? 20 units. Oops. So the period then should be, half the period is 20. What's a full period? Should be 40. And I know that one period is 2 pi absolute value c. So if I divide both sides by 2 pi, c is going to be 20 over pi. And I always choose c to be the positive result. Yes, sir.
I did it so like where it goes like did 2 pi I had it where it's 1/2 times 2 pi.
Sure. Yeah, you could have 1/2 times 2 pi equals 20. Yeah, doing the same thing. That's okay. AJ?
So why do you do half?
Well, we did, right? Because we don't know where it ends at. We don't know the point where the period ends at. That's why I settled for...
But you know the distance from the first point.
Yeah, but I did know where the second point was, the midway point was, because that's what I was given, right? Does that make sense? Oh boy. Oh no. All right. Shh. All right. So we have K. We have C. We know A is plus or minus 10. We still need to figure out whether A should be positive or negative. And we need to find H. So because we're using cosine, we always use the point 0,1 when we use cosine, which is a maximum on the parent function. From our resultant function, we have two choices. We can either use the minimum at 3,0 or the maximum at 2320. It doesn't matter which one you use. You can get a correct answer from both, but the answers will be different. Which one would we like to use, the min or the max? The max, I heard first. Okay. So the type of points we have tell us whether the A should be positive or negative, because these are both the same point. What does that tell us about the A? Positive. And then the x coordinates tell us the h. So because we're going from 0 to 23, the h has to be 23. Now that's everything we need. Now instead of writing 1 over 20 over pi, what do I usually do? I just write the reciprocal, pi over 20. And there's one possible answer. AJ?
Is H just like the amount between the x and the parent function and the x?
So if the x coordinate for the parent function is 0, then the h is always going to be the x from the resultant. That's why we choose to use the point 0,1 for cosine, because it has the x coordinate 0, so we get the h for free. And why we choose to use the point 0,0 for sine, because its x coordinate is 0, we get the h for free. Okay.
Do you always use 0, 1 when you're finding H?
For cosine,
For a cosine? You should always use it.
if I'm choosing to use cosine, it's so that I can use the point 0,1 because I have mins and maxes. If I had a midline point, I would not want to use cosine because then I'd have to use a midline point for cosine, which doesn't have an x coordinate of 0, which makes life a hassle. And that's what happens, I think, in problem 3 on the worksheet.
So
We give you a situation where you should use sine until you have to do cosine, and it's a hassle.
So what would you do if it was a sine?
For this one,
Yeah, like in a different one if it gives you a midpoint.
I do the same thing. It's just 0, 0 here. So again, the x coordinate for the resultant is the h. As long as that x coordinate from the parent function is 0, the h is the x coordinate from the resultant. Mhm. Does that feel?
Yeah.
Okay. Peyton, did I see your hand up earlier? Okay. That's okay. What do you guys think?
I think so, we're ready.
Okay. I feel like we're in Remember the Titans right now. All right, well, let's do this.